Alright, so we're going to be talking about two variable systems using graphs and tables. What does the solution of a system of linear equations represent? And we're going to be solving systems of linear equations using a graph or table. So a consistent system has at least one solution. An inconsistent system has no solution. And then a system that is dependent if it has infinitely many solutions. And it's considered independent if it has either a single solution or no solution. So in the first case, we have intersecting lines. This is the most common one that you usually see when we're talking about systems. And this one has one solution. And that one solution is where the two lines intersect. So we call that the solution. This is going to be consistent because we have at least one solution. And this is also going to be independent because it has a single solution or no solution. So next we're going to talk about the case where lines overlap. Okay, they basically just overlap on each other. So overlapping lines have infinite solutions. And that's because they touch at every single point for eternity on both ends, negative and positive infinity. So this is considered consistent because it has at least one solution, considering it has infinite solutions. And this is considered dependent because it has infinitely many solutions. Next is parallel lines. Oh, I'm sorry. Oh, okay. I'm sorry about that. I was like going on and on. Parallel lines have no solution, okay, because they never intersect. And we consider these to be inconsistent because they have no solution, but they're considered to be independent because they have no solution. So that's what your check boxes are going to look like, okay? So now that we did that, let's do an example. So the first thing you want to do in one of these examples is you want to get each of your equations into the form of slope-intercept, so y equals mx plus b. So we're going to have to manipulate these to get them into slope-intercept form, okay? So I'm going to do this one in red so that you can follow along with me. Negative 3x plus 2y equals 8. So to get the y by itself, I'm going to add 3 on both sides. That's going to give me 2y equals 3x plus 8. I'm going to divide both sides by 2. And that leaves me with y equals 3/2 x plus 4. Now that I have that, I'm going to do the second one. Same procedure. I'm going to circle this one in blue so that you can follow along with me. So this is x plus 4y equals negative 12. I'm going to subtract the x on both sides. That's going to give me that's going to give me 4y equals negative x minus 12. Now negative x is the same thing as negative 1x. I'm going to divide both sides by 4. And that's going to give me y equals negative 1/4 x minus 3. So now that I have both of these, I'm going to plot them. So I'm going to plot the red one first. So I'll scroll up a little bit here so we can see it. So the red one has a y-intercept of what? Thank you. 1, 2, 3, 4. And it's going up 3 and over 2. So up 1, 2, 3 and over 1, 2. So as you can see, this one kind of starts going off the grid paper on the right. So I'm going to go down and to the left. So 1, 2, 3 over 1, 2. 1, 2, 3 over 1, 2. And it's going to look something like this. now I can draw a line through it. So this is like, if you want to use your colored pencils here, you can do 2 different color lines, whatever colors you have. And then for the next one, my y-intercept is -3, so down 1, 2, 3. And I'm going to go down 1 unit over 4 units. So down 1 over 1, 2, 3, 4. Somewhere over here. So I'm going to go this way. And 1, 2, 3, 4. It's going to be over here. So as you can see, my other line looks something like this. And now we have a system, right? So now we can determine the solution. So the solution is where they intersect, which is right here. So what would you call the solution as an ordered pair? Good, -4, -2, and that would be the answer to your question. So looking at the next question we're going to talk about in class, to save you the time and effort, these are the same 2 equations, so we don't have to resolve for them again. We can just rewrite it. So I think the first one was y equals 3/2 x plus 4, is that correct? And the second one was y equals -1/4 x minus 3. Okay. So we're going to use the table instead to find solutions. Now, I do want to let you know that using a table to find solutions is probably your last-ditch effort. It's not the best method, and that's because while you can always use a table, you have to choose your own x values. And think about these 2 lines. They go on for eternity, right? We don't know where they're going to intersect to find what x value to plug in. So the problem is it's hard to know where to start using points unless I give you an interval. So I'm just going to tell you what points we're going to use. And I know the answer, so because I know the answer, I can identify that. So we're going to plug in -8 and we're going to plug in -4. Now typically, I'm going to provide you an interval to tell you where to plug in because it would take you way too long to figure this out on your own if you weren't using other methods. So the goal today is to kind of learn the worst methods, the most difficult ones to use, and then we're going to learn about more reliable ones. So what I'm going to do at this point is I'm going to plug in -8 into both my equations. So plug in -8 for x and solve for y. So y equals 3/2 times -8 plus 4. That's going to give me -24 divided by 2 is -12. -12 plus 4 is -8. And then I'm going to do the same thing for the blue. I'm going to plug in -8. -1/4 times 8 is 2. 2 minus 3 is -1. So the goal here is to get your 2 y values to match, okay? So do my y values match on -8? No, that means that it's not a solution, okay? So we keep going, and let's try -4. So I'm going to plug in -4 up here into the first one. -4. -4 times 3 is -12. -12 divided by 2 is -6. -6 plus 4 is -2. And I'm also going to plug into this one. So y equals -1/4 times -4 minus 3. That would become 4/4 minus 3. 1 minus 3 is, what do you guys think? -2. So see how we see this as a solution here because the 2 y values match of the 2 different equations. So that means this is my coordinate. Okay, either one of the y's will do. -4, -2. And we already knew that because we already did the same exact question, but we did it graphically. Okay? So do we have any questions on this one? So basically you're just making a table and checking where the table has the same y values. Okay. So this is the last question on the first part of our notes today. So it says here, the birth lengths and growth rates of two species of shark are recorded below. If the growth rates stay the same, at what age? This is so slow. Would a Greenland shark and dogfish shark be the same length? So, to give you like a little bit of a backstory on this, what this is saying is, okay, these are two different species of shark. We have the Greenland shark and the dogfish shark, okay? And the Greenland shark is born and they're already 37 centimeters long. So that's how long they are when they're born. And the dogfish shark is 22 centimeters when it's born. Now, for the Greenland shark, they grow after they're born, they grow at a rate of 0.75 centimeters per year. So they basically grow 3/4 of a centimeter a year. And the dogfish shark grows 1.5 centimeters a year. So the dogfish shark grows at a faster rate but starts out smaller. So we're going to compare their growth rates together. So we're going to call the Greenland shark by Y1, and we're going to call the dogfish shark by Y2. Now, growth rate, anytime we're talking about rate, that's a variable rate, and we are usually indicating that this is the slope. Bathroom? Oh, okay. We're just indicating that this is the slope, okay? Now, birth length, is somebody's birth length ever going to change? That's pretty set in stone, right? So this is our constant. And in math, our constant in linear equations is known as our y-intercept, okay? Because that's the set rate that's not going to change. So now we're going to set up our equations. So Greenland is y1, so y1 is equal to our slope times x plus our birth length. So to explain what all of this stuff means, y is basically the current length after x number of years, okay? After x number of years. And x represents the age, basically. The number of years that the shark's been growing. And now we'll do the same thing for the dogfish shark. So that's going to be y2 is equal to 1.5 times x plus 22. So now we have linear equations for each type of shark. So now that we have that information, we're looking at our table here, and conveniently our table has given us x values, so we don't have to figure them out. So all you're going to do here is you're going to plug these x values in to each of the equations and record your answers. So for this particular question, I recommend just using a calculator because this is kind of like numbers that you're not going to be able to do in your head. So y1 is equal to 0.75 times 18 plus 37. That's the first thing we have to do. And we'll plug that into the calculator. 0.75 times 18 plus 37. That gives me 50.5. Okay? And I'm going to then plug in into y2 the same x value. So that's going to be 1.5 times x plus 22. So that's 1.5 times 18 plus 22. And that's 49. So as you can see, this means that at 18 years old, when each of the sharks are 18 years old, the Greenland shark is 50.5 centimeters and the dogfish shark is 49. So they haven't caught up to each other yet. So we have to keep going in our chart. So now I'm going to plug in 19, okay? I'm not going to show it, but I'll just plug it in on the calculator. So that's 0.75 times 19 plus 37. That gives me 51.25. And I'll do the same thing with the other equation. I'm going to plug in 19. And when I do that, I get 50.5. And now lastly, we'll do 20. So if I plug in 20 into the first equation, I get 0.75 times 20 plus 37, which is 52. And then I'm going to do the same thing in the other equation. So 1.5 times 20 plus 22. And what do you notice happens at 20 years?
They're the same.
Good, they're the same. The sharks basically catch up to be the same length. So what this is really saying is, while the Greenland shark basically is born longer, the dogfish shark grows more every year. So eventually, the dogfish shark catches up to the Greenland shark, right? Because they're going to eventually be the same length. And if I kept plugging in values, what do you think would happen?
Dogfish sharks would eventually grow to be a lot longer than the Greenland sharks.
Yeah, exactly, because its growth rate is faster. Does that make sense to everybody how that works? Okay. So take a 5-minute break and then we'll get started on the second section. This one you definitely need your colored pencils for, so just make sure you have those and they're sharp. I tried to make sure everybody got a sharpened one, at least enough to shade with it. Wednesdays feel so rushed.